Hello everyone. Today, I'm excited to present MATDIVERTS, a MATLAB-based dynamic intelligent vehicle routing and traffic simulation platform, powered by both MATLAB and Python. MATDIVERTS is designed with multiple layers and modules, each playing a crucial role in creating a comprehensive and adaptive traffic simulation environment. We begin with the input layer. In this layer, users provide the core simulation data, such as road network information, link and node data, speed parameters, and other essential traffic data. Additionally, users input vehicle-specific details like IDM parameters, vehicle link information, emission data, and emission models tailored to each vehicle. The input layer also supports OD matrix for the network, whether as a single OD matrix for the entire simulation or as time-dependent matrices. Users can further provide travel time prediction model, the simulation parameters, such as simulation times, update intervals, the percentage of connected vehicles, CVs, versus human-driven vehicles, and the desired routing objectives. Whether user equilibrium, system optimal, or eco-routing, the next level is the configuration layer. Here, one of the primary modules is responsible for creating the simulation's road network. This module efficiently builds a microscopic road network, though it also allows users to adjust layouts manually for non-traditional intersections. I'll demonstrate an example of how users can manually refine these intersection layouts. In the configuration layer, we also have a module for generating vehicle agents. When importing an OD matrix, whether it's a single matrix or a set of time-dependent matrices, this module constructs time-dependent demand loading profiles and, from these profiles, creates the vehicle agents. Another key component is the travel time prediction model, which integrates a Python-trained model into the MATDIVERTS environment, performing data processing to enable accurate travel time predictions. The Scenario Manager module takes care of managing simulation parameters and adjusting scenarios, while a dedicated routing module embedded at intersections directs vehicle routing. Moving to the traffic simulation layer, it actually consists of two sublayers, the network layer and the information layer. The network layer handles vehicle movement, simulating the road network and vehicle interactions. Meanwhile, the information layer focuses on communication between vehicles and intelligent intersections themselves, and roadside link units, using sensors to gather real-time data from the vehicles. Finally, we have the output layer, where users can access detailed data, including vehicle and link level statistics. If environmental metrics were provided at the start and eco-routing was applied, users can also retrieve environmental metrics. In addition, the output layer includes a visualization module, enabling users to view the simulation in real time or review it afterward, with options to fast forward, rewind, and track individual vehicles. I'll demonstrate this visualization capability shortly. This platform combines MATLAB for core simulation with Python, which powers the prediction models. MATDIVERTS uses the Intelligent Driver Model, IDM, for driver behavior modeling, and users can adjust the parameters. Two prediction models are integrated, one that combines LSTM and deep neural network, and another that relies on deep neural network alone. Users can import new models as needed. Now, let's delve into the network construction. Users input node and link data, specifying attributes like node coordinates, link directions, speed limits, and lane numbers. For standard intersections, the network is constructed automatically, producing well-aligned intersections. However, with complex intersections, such as the one labeled 5 here, where links intersect, users can manually adjust these configurations to avoid conflicts. Let's look at a demo of this process. As shown here, the platform allows users to zoom in on any section of the network to check if it's satisfactory. If changes are needed, users can modify intersections by drawing polygons, correcting link paths as needed. Once complete, the platform confirms the adjustments, and users can proceed with additional modifications if desired. This final preview shows the updated network layout, with links now properly aligned and intersections resolved. Next, we'll discuss the generation of vehicle agents. Using the OD matrix input, MATDIVERTS generates time-dependent demand profiles, loading demand at customizable intervals. By default, demand peaks during busy periods with a concave profile, although this can be adjusted in the demand module. From this, time-dependent OD matrices and vehicle agents are generated, incorporating assumptions about arrival patterns and inter-arrival times. The next module handles link travel time predictions. The default model is a LSTM plus full connected deep neural network, trained using PyTorch. This model is imported into MATLAB as an ONNX file, processed within the MATDIVERTS prediction module. Real-time link level data, such as travel time, speed, and density, is collected from link agents, normalized, and used to forecast future travel times. As for visualization options, in this sample network, users can fast forward, pause, rewind, and restart the simulation. These controls enable flexible analysis of the simulation in action. Here, we see the MATDIVERTS simulation of downtown Toronto. Users can zoom in or out, examining specific areas within the network. Finally, let's look at single vehicle tracking. This option enables faster visualizations by focusing on an individual vehicle's journey without simulating the entire network. Users can set a radius around the vehicle to simulate its immediate surroundings. Currently set to 100 meters in this example. To wrap up, let's go over a quick summary of MATDIVERTS and its unique benefits. MATDIVERTS is a MATLAB-based platform designed for advanced, customizable traffic simulations. Leveraging the combined power of MATLAB and Python, it's ideal for traffic researchers and automotive developers, especially those in the autonomous vehicle space, as it offers a modular structure and a wide range of customization options. Some of the key benefits include a highly modular design that allows researchers to easily modify individual components. Seamless integration between MATLAB and Python, which supports complex, data-driven simulations and predictive modeling. Flexible routing objectives, like eco-routing and system optimization, that allow for diverse simulation needs. And finally, interactive visualization tools that make it easy to observe and analyze simulation results in real time. In short, MATDIVERTS is an excellent choice for researchers and developers looking for an adaptive, versatile, and data-centric approach to vehicle routing and traffic simulation. Thank you so much for watching.